Hello, thank you for joining us. Today we're going to talk about how low temperature conditions affect batteries you use every day. Has this ever happened to you? You're outside on a cold winter day and you go to make a call, only to have your phone immediately die. Or you go to drive your electric vehicle, but it very quickly loses its battery. What caused these low temperature issues? Most electronics, like smartphones, iPads, and headsets, use lithium-ion batteries as their power source. So do electric vehicles. Let's first review the configurations for the most common 18650 lithium-ion battery, which is composed of an anode, a cathode, and a separator. The anode is graphite-coated copper, and the cathode is a lithium transition metal oxide coated on aluminum. The separators are a thin layer of polymer which is soaked with an electrolyte and are used to prevent a short circuit between the anode and the cathode. Without this separator, batteries would quickly accumulate heat, eventually catching fire or exploding. So how come these lithium-ion batteries aren't working well in the winter? First, let's look at Ohm's law. Ohm's law states that current is equal to voltage over resistance. Resistance is determined by the internal properties of the materials and is equal to the length of the resistor over its cross-sectional area times its conductivity. Conductivity can be separated into electrical conductivity, which determines the mobility of electrons, as well as ionic conductivity, which determines the mobility of lithium ions. Let's have a look at them one by one. First, we'll have a look at how metals conduct electrons. Metals conduct electrons by the movement of free electrons. However, these free electrons can also move randomly. Low temperatures can suppress the random movement of these electrons, thus increasing their electrical conductivity. So what about the ionic conductivity? Lithium ions need to cross an energy barrier in order to diffuse into a solid electrode material. As the temperature lowers, ions need to jump across a higher energy barrier, making it harder for them to move. Due to this, the ionic conductivity of solid electrode materials is going to decrease as the temperature decreases. Current commercial electrolytes use lithium hexafluorophosphate in EC-DEC, where EC and DEC are organic solvents. Based on the experimental results, the ionic conductivity decreases several orders of magnitude under low temperature. And we can think of this like a fish in water. Lithium ions are like the fish swimming through the electrolyte, which is the water. But as the water gets colder and colder, it hardens, freezing the fish so that they can't move. Briefly, as the temperature lowers, the electrical conductivity increases, but the anionic conductivity decreases and becomes the limiting factor in the overall performance. Under this low temperature, ionic conductivity becomes like a short board in a wood bucket or the weakest link in a chain. Eventually, new lithium-ion batteries will be applied to extreme conditions such as satellites. And what about high temperatures? How do they affect the battery performance? For these answers and more like them, make sure to subscribe and wait for the next video. Thanks.